Hello everyone, welcome back to my channel. Today I'm going to continue chapter 6 searching concept. Last class we had discussed linear search and its working method, algorithm and program. And today's class we are going to discuss what is the meaning of binary search and algorithm, working process, program, and also we are going to discuss the hashing algorithm, program and collision technique. Okay, first we will start with the binary search. What is the meaning of binary search? And it is an efficient method to search for a key in a sorted list. So here the very important thing in binary search, the first point, your list should be sorted, which means it should be in the proper ascending order. Okay, because everything we are doing it with the ascending order. So the binary search also you have to mention inside the list should be in the ascending order. That's what it has mentioned. It is a sorted list. Then only it is easy for you to identify your key. Key means what? Searching element. Okay, and how the binary search it will work. See, for example, if you have a list, it will divide the list into half. Okay, and you have to compare first with the middle element. Whatever the middle element, you are going to compare it with that, whether the searching element is equal to the middle element. If it is equal, it will give which position it is there. Otherwise you are going to search. If the middle element is greater than the searching element, then the search will be starting on the right side. If it is less than, the searching will be starting on the left side. So this is what the binary search will be working. Clear now? That's what they have mentioned. The search will happen. You have to divide the list into half, and you have to compare it with the middle element of the current range repeatedly. Clear? And it is one of the efficient method to search a key. Now, how can you find out the middle element? Very simple. If you have a list of even numbers, if I have a list of even numbers of 10, then the middle position is calculated by using the floor division, which means 10, 10 by 2. What is it answer? So 10 by 2, the quotient is what? The 5. But 5 point, we are not getting it, right? Floor division, I hope everyone remember. It will remove the point and whatever the number is there, you will get it. But here it is an even number, right? So directly you got the answer. So the middle element is the fifth element is the middle element, okay? But in case if you are getting 9, 9 by 2, what is the answer? It will come as a 4.5, right? So 4.5 means what is the middle element? You have to consider 4 because we are using what? Floor division. Clear now? This is way you have to find out the middle element. Now let's see the working process. This is a two working process. I want to show it to you. The first working process is a very best case. For example, I want to find out the element 23 here, right? But what is the list size? So it is list size is 16. 16 is the index. So 16 by 2. What is the mid element? Mid element is 20. Mid element is 8. So you have to find out what? 23. How the binary search working? Directly it will come to the 23. If you compare it with linear search will check one by one, then come to this 23 position. But here in binary search, first it will divide the number into half. Directly it is coming to the middle element. If the middle element is equal to the searching element, then that is correct. Only one step. So this is the best case of the binary search. And again, the next one you can see here, the second example. I want to find out the number is 37. So 37 is my number. So you can see here again the 16 index. So 16 by 2 is a 8 is a middle element. But middle element here it is not equal to 37. Now after that where the searching is starting, that is only important as I told you. So 37 is bigger than the middle element. 23 is smaller. But 37 is bigger than the middle element. So the searching will start only from this direction, right direction. It will just omit the left direction. You can see how it is moving. Now after finding out it is not there, now you can consider this becomes the first element, this becomes the last element. Again you are going to find out 9 plus 16 by 2. So then it will become 12 is the middle element. Again it is finding out 12. So 12 is which element? 41. 41 also is not equal to 37. So what it will do again? Again the searching it will start with 37 is less than 41. So the searching where it will happen? It will happen to this left hand side only. Okay, you can see here, it is not there. Now the searching will be starting at the right side. Again, it is not there, then left side. Again, you can see it is finding out the middle position there. Is this way it will work for the binary search. So only steps 3, you can able to find out the position. Now we can see the algorithm. Now let's see the algorithm. So algorithm of binary search, I am giving here the binary search is my name of my algorithm, and I am passing to argument num list and key. Okay, key is nothing but searching element. Now step 1 is what? Set first equal to 0, which means the first element is 0, last equal to n minus 1. N minus 1 is nothing but the last element. N is length of the list, n minus 1 is last element. And calculate first what you have to calculate. You are going to calculate the middle element. How do you calculate? First plus last and floor division by 2. And you are going to search here while first is less than or equal to last. You are giving the condition here. So first should be less than or equal to last. Then you are repeating step 4. If num list of mid. So if num list of mid equal to key, as we discussed in the first example, if the num list of mid, which means the 23 is equal to key, then what happened? Then the print element found at the position. We are printing here the position, not the index. I hope everyone is clear. In the linear search example also we have given. If you are having a list L1, 2, 3 and the index number is 0, 1 and 2. This is the index number. So index number of mid is what? For example, this is a mid element. Index is nothing but 1. But what is the position? This is the first position. 1 is the first position. This is the second position. That is what I have given, mid plus 1. Then you have to stop. Otherwise, what you have to do, you have to check if num list of mid, this num list of mid should be greater than key. If it is greater than, then the right side the searching will happen, right? So you are setting the first equal to mid plus 1. Otherwise, the left side if it is happening, you are setting the last equal to mid minus 1. If nothing it is there, if the key element is not present in the list, then you are printing what? Search is unsuccessful. Now let's see, this is my list. It consists of 10 elements and I am arranging it in the ascending order and determine the number of comparison linear, it's a binary search. Makes to search for key is 10. Okay. Okay. Now the key should be 10. Now this is my index value I have mentioned and this is the table. This table, whatever is there in the algorithm I have mentioned. So what is the first iteration one starting? What is the first is nothing but 0 because 0 index. What is the last index? Last index is 9. And what is the mid value? How can you find out the mid value? 0 plus 9. Then you have to mention what? By 2. Which means what is the answer? The answer is 4.5. So what you have to consider 4.5 means 4. So this 4 is my mid position now. Okay. Now L of mid. What is L of mid? L is my list of the name. Mid is 7. L of mid is 7. 7 equal to key. K is what? Key is what? 10. So 7 equal to 10? No. The answer is what? No. Now you are going to search here. Key is greater than L of mid. What is key? Key is 10. It is greater than L of mid is what? 7. If it is greater than 7, yes, the condition is what? The condition is true. Yes, it is greater than 7. So what you have to do? First equal to mid plus 7 you are going to mention. So you can mention here yes and first equal to what? I am not writing completely. So first equal to what is mid? Mid is 4. So 4 plus 1 is 5 you are going to mention it. Clear? If it is greater than, so no need to see the less than. Okay, so this line you can skip it for the first iteration. Again, you are going to set what? First just change it to what? 5. So 5 and last is 9. Now the searching will happen to this to here only. So this one will be omitted. Okay, the left side part will be omitted. Now you are going to find out what? Mid position. How can you find out? 5 plus 9. 5 plus 9 by 2. So what is the answer? So 5 plus 9 by 2 is nothing but 7. Right? So 7 is the answer. So 7th position is your mid position now, second time. So what is the element here? 12. So L of mid is 12. So 12 equal to 10. What is the condition? The condition is false. If the condition is false, key is greater than, you are going to find out the key whether it is greater than or less than. So what is the key? 10. So 10 is greater than, what is the element here? 12. No, 10 is not greater than 12. So the answer is no. If it is answer is no, it will go to the next step. Then key is less than L of mid. What is key? Key is 10. 10 is less than 12. The condition is what? Yes. If it is yes, what you have to change it? Last element you are going to change is mid minus 1. What is the mid? 7. So 7 minus 1 is 6. Understood everybody? Now the first element is same only, 5 only, it is keep on continuing, and the last element instead of 9 you change it to what? 6. Now again you are going to find out the mid position. So 5 plus 6. What is 5 plus 6? 5 plus 6 is 11 by 2. So what is the answer is 5 only. You have to take it as the integer part, 5. So 5. So 5 is what? This is a fifth index. So what is the element here? 9. So 9 equal to 10. The condition is what again? Again the condition is false. Now after that what you have to check? Whether the key is 10 is greater than 9. L of mid does what? 9. 10 is greater than 9? Yes, the condition is true here. If the condition is true, what you have to change? First position you have to change. So first is what? First position, mid plus 1. What is mid? 5. So 5 plus 1 is 6. So 5 plus 1 is 6. Now this column we no need to do it because already we find out key is greater than L of mid. Now again first is what? First we have to change it to 6. Last it is continuing the same thing. Now 6 plus 6. So 6 plus 6 is what? 6 plus 6 is 12. 12 by 2. What is the answer? 12 by 2 is 6. Is the middle element. What is the middle element here? 10. So 10 equal to 10. Yes, 10 equal to 10. The condition is now what? True. Right? The condition is true. Now the loop will terminate here. Okay. Now what is the question they asked? Determine the number of comparison. How many comparison we have done? 4 comparison we have done. And where you are finding the position? The position is at what position? It is in the which position? 10th is in 1, 2, 3, 4, 5, 6, 7. So the 7th position it is there. So you have done 4 comparison and you are finding out the element in 7th position. Clear now everybody? So whatever the mid value you are finding out, plus 1 will be the position. This is what you have to identify the searching element. Better you have to draw this table and do it. Then it will be easy for you to write the algorithm. Okay, now let's see the program. I'll show the program in ideally. Okay, so this is a program of binary search. Again, I'm using it here. L is my list and I'm using eval function. Eval function, you have to use the square bracket to collect all the list element. And I'm giving here DEF binary means I'm creating a function here. And I'm not passing any argument. L dot sort of. What is the meaning of this? In case if the user is giving no unsorted element, you are giving here as a sorted one. L dot sort means it will sort automatically. After that you are printing the L. Now X is nothing but key. You are asking the user to enter which item they want to search it. After that you are setting first equal to 0, last equal to len of L minus 1 and found equal to false. So if found will take only 2 value, one is false, another one is true. Okay, if it is true, you are finding out the position. Now, while condition you are mentioning, first should be less than or equal to last. And if it is not found, what you have to do? You have to find out the middle position. Mid equal to first plus last by 2. The same formula. After that, if L of mid equal to X, you are finding out what? The L of mid, the first time the middle element. If it is equal to searching element, you are converting found equal to true. LF, you're giving the LF, X is greater than. In case if you're not finding out, what will happen? You're going to find out whether it is the right side searching or left side searching. So for that, what you have to do, X is the searching element should be greater than L of mid, means first you are going to change it. If it is greater than, you are going to change it. The first position is equal to mid plus 1. Otherwise, last equal to mid minus 1. Otherwise means what? That should be less than, right? Mid last equal to mid minus 1. If found equal to true. So whenever the condition is true, then your number found at the position mid plus 1. Otherwise, number not found. Easy? Okay. Now, I'll run the program. Now, I'm giving the key. You can see 1, 5, 2, 3, 6. Now, it is not in the sorted order. Now, you can see we have mentioned L dot sort. It is in the sorted order. Enter the number you want to search. 5, I want to search. You can see number found at position 4. 1, 2, 3, 4th position. Number is finding out. Okay. Now, I'm showing you the other example. Now if I'm giving 1, 5, I'm giving in the sorted form. Again your list will be same. Now I want to find out 8. Number not found. I hope that both the condition is satisfied. Everyone understood the concept of binary search. Very easy. You have to find out the middle element. After that, if it is the same searching element, you have to print the middle element plus 1 for the position. Otherwise, you have to search. If it is a greater than, means you are going to change the position of first. Otherwise, you have to change the position of last. Clear now? Okay. The next concept is linear versus binary. So what is a linear search? What are the things you have discussed in linear? Linear search, check each individual item separately from the beginning. So individually it is going to check it, right? So if it is a list, 1, 2, 3, 4. So one by one it is going to check and it is going to finding out. But binary search, it is going to find out what? The middle element of a sorted list. Okay. But here in the linear search, it is not necessary it should be sorted. It can be unsorted also. Okay. So this can work with sorted also, unsorted also. But in binary search, you have to make sure that it should be in either ascending order or descending order. But according to our curriculum, you have to mention in the ascending order. Okay. And next one is what it will happen. And each comparison, if the list is very long, you have to go till the end of the list in linear search. But in binary search, your list you are going to divide into half of it. Okay. And the time complexity. The time complexity of linear search, if you're taking it, O of n. Okay. And time complexity of binary searches, O of log n. So this is no need to go into the detail. Just remember that it may come in one marker. Okay. And next one, this linear search is not suited for the large data set. But here it is an efficient one. Okay. Because you are going to anyway divide the list into half. Okay. And what is the example? Searching a word in a randomly returned test. But here randomly you can write the a text in the file, means easily you can do it with a linear search. But here alphabetically you have to do it in the dictionary. Okay, then the binary search can be helpful. So these are the difference between linear search and binary search. And the next concept is hashing algorithm. So hashing algorithm is very efficient algorithm. Within one comparison only you can do the searching element. So that is what it has mentioned. It is a single step to find the searching element and it is a direct access. And which method we will be, one of them, there are different hashing algorithm or method or formula are there, but we are going to use a simple hash function called reminder method. So what you will be having, you will be having the hash table and the size also will be given and you are dividing an element from a list. So the reminder method only we are going to use it. So this is the formula for that. So what is that? H of element equal to element module size of hash table. So this formula, by using the formula, we are going to create a hash table. Okay. Now let's see. So this is an example of it. Use a hash function, h of element module 10. I am mentioning here hash function, you are having 10 element only to store the collection of numbers. So these are the list in a hash table. So display the hash table created. Search the value 11, 44, 88 and 121 are present in the hash table and display the result. So what I am going to do first, I am going to prepare the what are the elements are there. So whatever the elements I have given here, I have written it here. Now you are going to find out what is the hash value for that. Hash value is nothing but the index value. So for example, this 44, it will not be in zero index. It can be in, you have to find out the formula. You are going to use of the formula here. So h of element module 10. What is the element here? 44 module 10. Why I am using 10 is, I have given already, they are giving in your hash table, you will be having the 10. Okay, which means the 10 index are there. Okay, so for that, you are going to mention 10 here. So many of you ask me like, why it is only 10? Can't we have 7 or 8? Yes, you can have 7 or 8, but in your curriculum, they have given only with the one value as 10 only. So better we can, mostly they will give a question also module 10, but you can have 7 also, 6 also, 5 also. Okay, but in the question I have given module 10. So you have to prepare the hash table of 10 only. Okay, now I'm taking the 44. You are going to find out this 44 element, which index it is going to take place. So you are going to find out the remainder. So 44 module 10, what is the remainder? 4. So 4, what is the position? This is the position of 4. It will be taking here 44. Clear now? This is what it is going to take it. Now 121. I'm taking the 121. 121 mod 10. What is the reminder for that? 1 is the reminder. So which is the one position? This is the one position. In hash table, you are going to mention here what? 121. Okay. Next is 55. So 55 mod 10 is what? 5. So 5. So then 55 you are going to mention. So what is the index number of 55 is 5. And next one is a 33. 33 means 33 mod 10 is 3. So here the 33 it is going to take place. Again 110. 110 mod 10 is 0. So here 110. Next one is a 77. 77 means 7. So 77 and 22. 22 will occupy the second position and 66 means 6. So 66 will occupy the next position. Now what about this 2 remaining? So this will be occupied as none. So the none value will be created for this hash table. So this is what you will going to prepare the hash table. They will be giving the list of element. You have to apply the formula here. Whatever the element are there, you have to module 5. You are going to find out the reminder. Okay. What is the 10 here? In your hash table, you will have a 10 index. It starts from 0. So 10 index are there. So which element is going to take what index? You will be finding out and put it in the table. Clear now? This is what you are going to find out the hash table. Now the program, only the program, it is not a lab program also, but binary search, yes, it is a lab program. So here, what is the concept? One second. You can see here, I'm creating the hash find key. What is the key? Which key or want to finding out? And hash table. Hash table is my, you are going to create a hash table. If hash table of key module 10, what is the key? You are going to take the list, right? So this one. So 44 module 10, that is equal to key, which means that is equal to your index. So key is nothing but this is the key module 10, whatever the module 10, that is equal to index. Clear now? Now after that return key module 10 plus 1, which means that will be your position. Okay, else return none. So if I want to find out what is the 44, where the position is, it will be in the 1, 2, 3, 4, 5th position. But what is the index of the number is 4. Clear now? Okay. Next hash table I am creating everything as a none. Initially everything will be none in the hash table. After that only you are substituting with the value. Now we have created hash table of 10 position and print of hash table. Now L I am creating the same thing 44. I am giving the list and list also I am printing and for I in range of 0 comma len of L, which means it will start from the 0 index till last number. It is going to do the same calculation. Hash table of L of I. What is L of I? 44 module. The first time I will be taking 0 index, right? So 0 means what? 44 module tail equal to L of I, which means that will carry what? Whatever the position comes. So this will take it as a fourth position. Like that, it will go till the end of the list. After that, you are going to print what? Hash table. Hash table, how are we going to print out? 0 comma len of hash table by using the for loop. Hash index is nothing but I. So index you are printing. What is the value you are printing as hash table of I. Now after that, which number you want to search? It will search from the hash table. Then in case if the position is none means the key is not present in the table. Otherwise it will give you. Now I'll run the program. You can see you will get the answer like this. We have created the hash table of 10 position. Initially everything will be none. After that the list. Then you are going to hash index 0 means it is a 110, 121. So you can see whatever the answer we got it. Right? 110. 121, the same way we got it, right? The same way it is here. So now enter the number to be searched. If I want to mention here 77, which position? 77. Indexes 7 means it will be in the 8th position. This is what you have to present it. Clear now? So hash table everybody understood. It is very easy for you to identify the hash table. There is no any technique, only you have to use the formula and find out the index in the hash table. Next concept is collision. What is the meaning of collision is when two or more elements are mapped to the same index. So, for example, if you are using the index, sometimes index the remainder can be same. So that time what it will happen in the hash table, the collision will happen. So you can't put two elements into the same index. That particular situation only we can call it as a collision. There are some collision resolutions are there to deal with that. So all elements can be stored if even if their hash value is the same. So collision resolution, the technique, what it will help you is the data will not be lost or the data will not be overwriting. But we are not going to know there is no collision techniques are there in the curriculum. We are going to learn only the theoretical part. What is the meaning of collision means? What is the meaning of collision resolution? Okay. And what is the meaning of perfect hash function? This also may come in one marker. What is the meaning of perfect hash function is in case if you have a list which does not happen any collision, which means everything will have a unique index means that is nothing but the perfect hash function. So now recent example we have given, right? So if there is no certain situation, we got two no two element is holding the same index, right? So that is the example of perfect hash function, which means every element will have a unique index. Okay. And what are the other hashing methods are there? Modulo division method, integer division, shift folding, boundary folding, mixed square method, extraction, and radix transformation. So in your book, they have given only the name of it. There is no describe, okay. So they may ask you in 2 marker or 1 marker. Just remember all these names. Clear now? So these are the main concept of hashing technique. And main advantages of hashing technique is the amount of time. Even though in case if you have a larger list, you can just use the formula and find out the index and position. So one of the most efficient searching compared to linear and binary is hashing only. Clear? So this is the main concept of the chapter. So searching, we had discussed linear search, algorithm and program. Very, very important. Binary search, algorithm and program also is very important. And hashing, method and program. Program, there is no lab program for the hashing. Only just go through that. Okay. And what is the meaning of collision, perfect hash function and other hashing method. So today whatever we had discussed, linear search versus binary search, the complete point-wise explanation, and what is the meaning of perfect hash function, and advantages of hash function, collision resolution, everything the point wise I have given detailed in this book. So those who didn't purchase, please do the purchase, and you can contact this number for the purchase, or you can go to the Avenue Road and Sapna Book House. It is available, and you will be having a lot of MCQ, fill in the blanks, assertion type of question, and it is all in one book. You will be having a textbook, question bank with answer, and lab manual. And lab manual detailedly I have given input as well as the output. Directly you can copy it from your no notebook, record notebook. And there are some simplification I have mentioned in the YouTube. So please do watch that. It will be easy for you to understand the concept thoroughly. So those who didn't subscribe my channel, please do the subscription. And already those who bought this book, please do the feedback in the comment section. Thank you so much. Soon we will going to see the next chapter.